The engineers who will win in the next 5 years are the ones who will use. When I interned at Amazon 2 years ago, the amount of code that I wrote with AI was just 5%. But when I interned at Meta last year, the amount of code that I wrote with AI was about 95%. The job changed completely in 12 months, and most aspiring software engineers are preparing for the version that doesn't exist anymore. In this video, I'm going to be breaking down the shift happening in the software engineering industry and how you, as an aspiring software engineering student, can get ahead of them. Let me start by giving a little bit more context on those numbers because I think they paint the picture better than anything else. At Amazon, we had an internal chatbot, but it was similar to ChatGPT, how it was on its own website and people would use it to prompt for code here and there. But most of my work was still me writing functions and reading documentation and debugging by hand. It felt like a normal SWE internship. At Meta though, almost every production line of code that I wrote started with me prompting our internal chatbot that was built into the IDE itself. That meant my job kind of shifted from writing to editing and reviewing and verifying. Even though it was still a chatbot, it was significantly stronger because it was built into the IDE itself, so it had way more context than the one at Amazon did. This didn't really make the role any easier, it just made it different. I was shipping way more and the scope of what I could own went up significantly. But the actual skill went from, can I write this function, to can I prompt the model effectively, and can I figure out how I want this to be structured? Can I find bugs in the output that the model returns? That shift happened in just 12 months. At this point, it's guaranteed to happen everywhere. The question now is whether you are going to be preparing for a job that existed in 2023 or a job that's going to exist after you graduate. The biggest piece of advice I can give is this: start using AI like a tool that you can master. What that means for a software engineer is building a full stack complex app with AI. This app would have authentication, database, payments, real users. As you're building this, use Claude Code or Codex as your pair programmer all the way through. That'll get you to learn a lot more about how to code with AI versus just watching a YouTube tutorial and not doing anything yourself. When a recruiter or hiring manager looks at two candidates, one who built some type of to-do app over the weekend versus another one who built a full app with authentication and a real payment flow and actual users, that second person is going to win every single time. AI lets you be that second person now, even as a student without many resources. There's no real excuse for a thin portfolio. It's honestly not hard to get started. Install Claude Code and pick a problem in your real life that you actually want to tackle. One mistake that I made before I had started using Claude Code was that I wanted to make sure that I got my setup right, whether that was getting the right skills installed or using the right MCPs or CLI tools. I would just start by building, and then as you build, you can see what tools would be more useful for your use case. By me continuously waiting and trying to learn more ahead of time, it ended up with me just delaying my start date. You don't need to read the documentation cover to cover. You just need to open your terminal and start working. You'll pretty quickly figure out what works and what doesn't. Coding interviews are already changing. This is the part that most people are sleeping on, and it's gonna bite a lot of candidates in the next year or two. For example, Meta recently publicly came out and said that they're going to be changing their interview style to be AI assisted. What this means is that it's no longer going to be those classic data structures and algorithms types problems, but more so debugging something using AI or being able to understand a complex file system. The interviewer is going to want to see how you prompt, how you review output, how you might catch mistakes that the AI might make, and how you iterate on those mistakes to get to a better final product. This is a completely different skill compared to what most people are preparing for right now. You could leak code for 6 months and you would still bomb this type of interview if you never built something with AI. I think within the next year or two, most companies are going to follow this type of process. If your engineers are going to be spending 90+% of their time coding with AI, it makes no sense to interview them on a skill that they're rarely going to use at this point. Interviewing should match the work, and the work has changed. To prep for an AI-assisted coding interview, the only real way you can do that is by actively using AI-assisted coding. You have to pick up Claude Code or Codex, build something real, and pay attention to how your input interacts with the output from that specific model. You're going to have to notice when it makes mistakes and notice the patterns in your prompts that are leading to the best possible outputs. This is the awareness that interviewers are going to be looking for now. I will say it's important that you don't abandon data structures and algorithms entirely. Those fundamentals are going to be super important when you're evaluating the model's output, as well as you're just designing good systems. However, the ratio of your prep time should shift. If you used to spend 100% of your time on LeetCode, that should probably change to a 50-50 split, where 50% of the time you're still LeetCoding, but the other 50% of the time you're building something with AI. The final major shift I'm going to talk about now is how system design is going to be the most important thing for a software engineer to learn, even at a junior level. When AI can generate most of the individual code, the bottleneck becomes the architecture. How can you connect a backend to a front end, to a database, to an API? How do you handle scale? How do you handle failures? These are the questions that make or break a system. The role of a software engineer is shifting from writing individual lines of code to connecting these parts together. If you're a student, you probably have very little exposure to system design right now. Most universities' curriculums don't cover it, and most internship interviews don't test it. That's a gap, and a gap that you should work on closing before you apply to roles. I would start small, watch a few system design walkthroughs, read about how companies have designed specific products that are in use, things like caching, load balancing, sharding. Then, when you build your AI-assisted projects, actually take a second to think about the architecture. Don't let Claude just pick the stack for you. Make real decisions and think through about why you're using Postgres over Mongo, why you're caching with Redis, and why you're using a queue for that one async job. For new grad roles, system design rounds used to be rare. That's already changing. I personally had a system design round already this past year. The good news is system design has way less of a trick element than LeetCode. There's no patterns you're really memorizing. You're kind of just understanding trade-offs and thinking through why you made one decision over another. If you've built real projects with AI, you're gonna have decisions and trade-offs to talk about, which will make for a super strong system design interview. If I had to sum up the entire video in one sentence, it's this: the engineers who will win in the next 5 years are the ones who will use AI as a force multiplier, get really good at system design, and build real things instead of just grinding problems. This isn't a doom story. The opportunity right now is genuinely massive. A motivated student today can ship more, learn faster, and build a much stronger portfolio using the tools available. The tools right now would probably make a student engineer stronger than a funded team of 10 engineers a decade ago. And the best part is the tools aren't even super expensive. The only thing standing in between you and a great job is whether you actually make use of these tools. In my next video, I'm going to be discussing how you should go about learning data structures and algorithms in 2026 without wasting your time. Like and subscribe for more.